This is just going to have a bunch of factoring problems for those of you who are factoring challenged. So always check first if they have a greatest common factor. And when I look at this problem, this has an x times an x, and this has a 5 and 3 x's. And so these have 2 x's in common. So when you factor this out, it's x squared times 1 minus 5x. And so the zeros would be 0 or 1/5. So the first problem most of you will probably recognize as a simple trinomial, what multiplies to 6 that adds to 5. But look down here, this is also a what multiplies to 6 that adds to 5 question. It's just in the top problem, the first number is the perfect square x times x. In the bottom problem, it's the perfect square x squared times x squared. So the first question is what multiplies to 6, positive 6 that adds to a positive 5, and that would be negative 2 times negative 3. And so if you were giving the zeros for this function would be 2 or 3. In the second question, it's asking what multiplies to negative 6 that adds to negative 5. So now I have to multiply to negative 6, so it would be negative 6 and positive 1. So here my zeros would be plus or minus I and plus or minus the square root of 6. Notice that this problem is a 4th degree equation and it has 4 zeros. The first problem was only squared and it only had 2 solutions. Some problems will have more than one way to factor. Like if I look at this problem and I always check first if they have something in common, these have an x in common, but after I take that x out, I'm still left with a simple trinomial. And so now I'm what multiplies to 24 that adds to 10. That would be negative 12 times positive 2. And this problem has 3 zeros. The 3 zeros are at 0, 12, and negative 2. Most students that have a really hard time graphing tend to get stuck on problems that are general trinomials like this. And so I want to talk about how to use FOIL with guess and check. This problem, you don't know if it's going to be 10x times x or if it's going to be 5x times 2x to get the first term. But when you talk about things called means and extremes, it might make sense to you that if you multiply, like let's just say you had this first problem and you put in 12 and 1 to make 12, your outside is 120 and your inside is 1. And so if you have huge numbers like 10 and 12, you have really extreme values for the middle term, and we don't want an extreme value for the middle term. We want 7. And since 7 is not very extreme, it's going to be more likely that I'm going to choose 5 and 2 for my 10 so I can get smaller numbers. So the first term has to be 10, and then if you look at the last term has to be negative 12. So I need to concentrate on making the first term 10 and the last term negative 12. And then I also have to check the outside and the inside with FOIL in order to make sure I get the middle term of 7. So if I put in, let's say, 2 and 6 to make 12, that makes my outside term 30 and my inside term 4, and that's not going to make 7. And so I just need to keep erasing and trying different numbers until I get a combination. Like for example, if I try 3 and 4, my outside is 20, 5 times 4 is 20, my inside is 6, 20 and 6 don't make 7. So I erase and I try again, and I get 4 and 3. And now my outside is 15x and my inside is 8x, and I can get a 7 out of an 8 and a 15. If the 15 is positive, that means my positive goes here, and my 8 is negative, so my negative goes there, this gives me a problem that has zeros at 4/5 and negative 3/2. Now, if you have a problem that is a general trinomial, it could be easier to use a quadratic equation. But sometimes your teacher will give you a general trinomial, and you can tell it's a general trinomial again if it's got this letter A in front of the x squared term. So as soon as you see a number there, you have to try it like this. And for this problem, the general trinomial, you can't use the quadratic equation because it's a fourth degree equation. So you're going to have to be able to work out what the first term is. In this case, the first term is going to be 2x times x. And then you're going to have to check numbers for the last term. Last term is 5. So I'm going to try 5 and 1 first. And if I try 5 and 1, that makes my outside 2x and my inside 5x. And these two numbers together have to make the middle term. And if I look from here up to here, my middle term is 9. 5 and 2 are not going to give me a middle term of 9. So that's where I get out my eraser and I try doing it over again. So that doesn't work. There's only one other thing that multiplies to 5. That's 1 times 5. So if I make this 1 and I make this 5, now my outside is 10x and my inside is 1x, and I have to make that outside and inside make the middle term 9x. And okay, these need to be squared because my middle term has to be squared. And if I make the 10 positive and the 1 negative, I'll get my middle term. So this is 2x squared minus 1 times x squared plus 5. And if you look to the roots of this problem, it's plus or minus I square root 5 for this one, and plus or minus the square root of a half, which is the square root of 2 over 2 for the other one, which means you never could have gotten the answers to this problem if you had tried to do synthetic division or long division, because all of the roots are irrational or imaginary. So when faced with a problem like this, you have to be able to factor. You also have to be able to see factoring within factoring. Like when I look at this, I see 2x cubed squared minus 4 squared. And so I see this problem as a difference of perfect squares. That's 2x to the third minus 4 times 2x to the third plus 4. And so this problem, if you were looking for its roots, this would be x cubed is equal to 2, and this would be x cubed is equal to negative 2. And so the solutions for this problem would end up being, or at least the real solutions, would end up being the cube root of 2 or the cube root of negative 2. Those are the real solutions. It also has complex solutions, but we're not going to find the complex solutions for this one right now. This problem you'll also recognize as a difference of perfect squares. So if I were solving it for all of its solutions, and keep in mind this has 4 solutions, this is going to be x squared minus 4 times x squared plus 4, giving us 2 real solutions, positive and negative 2, and 2 imaginary solutions, plus and minus 2i.